Welcome to SyntaxGrid. Today, we're diving into the world of linear regression. Stick around to explore how linear regression works.
Covering linear regression, code implementation, hyperparameter tuning, and cross-validation. Each section is designed to flow naturally into the next, with clear explanations for both concepts and code. Linear regression is one of the foundational techniques in machine learning and statistics. It's a method used to model the relationship between two variables. This is valuable across fields, from predicting sales trends in marketing to forecasting health outcomes in medical research. Let's start with a quick overview of linear regression. In simple linear regression, we're looking at how a single independent variable, and that's x, predicts a dependent variable y. We do this by finding the best fit line that represents this relationship. The equation for a linear model looks like this. Here, b0 is the intercept, b1 is the slope of the line, and epsilon represents error, since no model perfectly fits real-world data. We also have multiple linear regression, which extends this concept by including more than one independent variable, like x1, x2, dots, xn. Both types aim to predict y by capturing a linear relationship, but multiple linear regression uses more variables to do so. To help visualize this, imagine a scatter plot with data points. Our goal is to fit a line that minimizes the error or distance between the line and each data point. Now let's dive into the code to implement linear regression in Python. We'll need a few essential libraries, including Scikit-learn for modeling, training, and evaluation. Python from Scikit-learn.linearModel, import linear regression, Ridge from Scikit-learn.model-selection, import train test split, grid search CV from Scikit-learn.metrics, import mean squared error, R2 score. Here's what each import does. Linear regression is our main model for simple and multiple linear regression. Train test split helps us divide our data into training and test sets. Grid search CV will allow us to tune hyperparameters, and like over there, mean squared error and R2 score are metrics to evaluate model performance. Let's prepare our data. Suppose we have a data set where we want to predict test scores based on hours studied. We'll assign hours studied to x and test score to y. Python x equals data hours studied. Independent variable y equals data test score. Dependent variable. Split data into training and testing sets. X-train, X-test, Y-train, Y-test equals train test split, X, Y, test size equals 0.2, random state equals 42. This code splits the data with 80% for training and 20% for testing. 4. Implementing the linear regression model. Python model equals linear regression, model.fit, X-train, Y-train. Python ypred equals model.predict, X-test. Now let's evaluate how well our model performed. Two common metrics are mean squared error, MSE, and R squared, R-fre. Python MSE equals mean squared error, Y-test, ypred. R2 equals R2 score, Y-test, ypred. Print mean squared error, MSE. Print R squared, R2. MSE shows the average squared difference between predicted and actual values, so a lower MSE means better performance. R squared tells us how much of the variance in Y is explained by our model, with higher values being better. Let's talk about hyperparameter tuning. Linear regression itself has few hyperparameters, but we can add regularization to improve performance, especially if the data is complex. Ridge regression is a form of linear regression that adds a penalty to large coefficients, which helps reduce overfitting. The main hyperparameter here is alpha, which controls the penalty's strength. We'll use grid search CV to find the best alpha value automatically. Grid search CV tries each alpha value with cross-validation, which splits the training data multiple times to validate the model, making our results more robust. After running grid search CV, we can find the best alpha value and the corresponding R-squared score. Python print, best alpha, grid search.bestparams, print, best R-squared, grid search.best score. The best alpha value is the one that gives the highest R-squared score during cross-validation. To make this more relatable, let's look at real-world applications of linear regression with tuning. In finance, we can predict stock prices or economic trends. In healthcare, linear regression helps model relationships between lifestyle factors and health outcomes. And in marketing, it can show how changes in ad spending influence sales. These scenarios benefit from tuning hyperparameters to get accurate, dependable predictions, making linear regression a versatile tool in predictive analytics. I encourage you to try these steps with your own data and experiment with tuning to see how it can make your models more accurate. For those interested in more, this script provides clear, actionable steps for explaining both the concept and practical implementation of linear regression in Python. Each section flows into the next, with code and concepts explained side by side for a cohesive learning experience.
Thanks for joining me on this journey through linear regression. I hope this video gave you a clearer picture of how it's used and why it's so valuable in data science. If you're curious to learn more about machine learning and its applications, check out our other videos on SyntaxGrid. See you in the next one.